think I'll try this one first. So hi, I'm Bassam. I'm the CEO and founder of a company called Upbound, a new startup in Seattle in this space, in the infrastructure space. And we are the sponsors of a CNCF project called Rook, which is really about dealing with stateful workloads on Kubernetes. So what I hope to do today is to kind of walk through some of the choices you have when you're running stateful workloads or interacting with stateful workloads on Kubernetes. Some of these are not so obvious when people think about running state and stateful in Kubernetes. So I hope to kind of walk through some choices and talk through some of the trade-offs, but feel free to ask questions, and happy to have this a little bit of a live discussion. So show of hands, how many of you guys have, well, let's start with the easy one, heard of Kubernetes? Okay, great. You're in the right room. How many are deploying Kubernetes today in production? Okay, so about 10-ish people. How many of you are running stateful workloads on Kubernetes? So, one. Great. Okay.
Do you mean that the service itself is met the stateful services in Kubernetes, or Kubernetes is accessing? So
the question was running the stateful services themselves on Kubernetes or accessing stateful services through Kubernetes, and I meant the former. So I think there was one person. So just a level set, I think people describe Kubernetes in a lot of different ways. I'd like to think of it as the cluster operating system, just like Linux is an operating system for a single machine or a node. I think of Kubernetes as the operating system for the cluster. And as an operating system, it does a number of things. Most people kind of refer to Kubernetes as the container orchestration, which it does. But it does a bunch of other stuff that people don't talk about or don't highlight as much as container orchestration. So it's lifecycle management, scaling, all these automated features for rollout and rollback, service discovery. It's got its own views on networking. So it starts to look more like an operating system for the cluster than it does just, say, a scheduler or orchestrator. The thing that I think gets probably the least amount of attention when people talk about Kubernetes is the fact that it actually exposes a portable cloud API. And that is an important strategic piece because it is, trying to deliver on the promise of writing once and running everywhere. And if you were to put your stuff in containers and run it in Kubernetes, for the most part, that's true. Kubernetes today is supported in all the different public clouds, including Amazon now, and by most platform vendors, including Docker and Mesosphere, and everybody's got some kind of Kubernetes implementation or a managed Kubernetes service. So if you were to put your code in containers and you don't really need anything outside of the Kubernetes space, the write once, run everywhere is actually fairly true. And we're seeing a lot more companies converging on Kubernetes and talking about how that's become a productivity enhancement, or how they've changed their entire operation to be Kubernetes-based, and how they've seen productivity wins as a result of doing that. The story falls short when it comes to storage. And so let me first level set on how we think about storage. So to me, storage is really anything that can survive the compute lifecycle. So in a dynamic environment like containers come and go all the time. Any kind of state that needs to survive beyond the lifecycle of a container, or a pod, or a function is probably in the definition of storage. And so you'll hear different terms of this. You'll hear stateful, stateless. None of them are perfect. Persistent storage, you'll hear durable, long-lived. Those are all examples of how people describe what we're talking about here. And then there are different forms of storage. And so the most obvious ones that people think of when you think of storage is blocks and files. So these are volumes, things that you mount into your containers, but there are lots of different kinds. So it's objects, records, key value stores, queues. All these things are also stateful or persistent types of storage that need to exist beyond the compute lifecycle. So let's bring the two together. If we think about Kubernetes as being this platform abstraction and cluster operating system, and if we think about storage as being an important piece of every application and every service, how do they come together? And I keep hitting the mic. So, well, Kubernetes defines an abstraction, a portable abstraction for one form of storage, volumes. So that's block storage and file storage. So if you were to use the volume abstraction in the form of, say on the left here, persistent volume claim, it's an API that Kubernetes exposes, which is a request by essentially to provision a volume, and then it describes the properties of this volume. So if you wanted the size or the speed or any kind of annotations, you could describe that on the volume itself. And then on the right here, we have a pod that's using this volume. And if you're using this abstraction, you're actually able to run your service and consume volumes, block or file, anywhere that Kubernetes runs. For the most part, it still fits the write once, run everywhere mantra. And unfortunately, this is the only abstraction that Kubernetes has related to stateful workloads. It stops here with volumes. Almost everything else that's exposed, like how to run and scale services, are all mostly on the computation or on the networking side, not on the storage and stateful side. And so if you're using Kubernetes, putting your stuff in containers, even using the volume abstraction, you're able to run your containers and you're able to interact with storage services that, for the most part, live outside of your Kubernetes cluster. So on the right here, whether it's public cloud managed services, things like EBS or Google Persistent Disk, or provide volumes to Kubernetes, or if it's on-premise and you're using things like Gluster or Ceph or any of the storage systems that are available, you're essentially able to write your application and it consumes these volumes that are exposed by services that are outside of the Kubernetes cluster. And so what I want to do now is I want to introduce the Rook project and kind of walk you through some more options that are available to you when you're thinking about running state and interacting with stateful workloads on Kubernetes. So Rook is a cloud-native storage orchestrator. Think of it as an extension to Kubernetes that adds, one, more abstractions beyond volumes, and two, the ability to run stateful storage services inside the Kubernetes cluster. So those are the two things that Rook provides. It's open source, it's Apache 2.0 license, and it's hosted by the Cloud Native Compute Foundation. So it's a project for everyone. My company, Upbound, is a sponsor of the project, and that's why we like to kind of walk around and talk about it. So let me walk you through what that means. So what Rook does is it helps storage systems, things like Ceph, CockroachDB, Minio, Nexenta, and there's a bunch more coming, essentially run like a service on top of a Kubernetes cluster. So, and it does that by automating all the things that people usually do by scripts or others into logic that helps these services run within the cluster. And then extends Kubernetes to be able to essentially provide these abstractions that run on these services. And we'll walk through this. So for example, with something like Rook, you now, if you wanted to, if that makes sense for your deployment can run storage systems as if they were managed services inside your Kubernetes cluster. So think a typical deployment, say a bare metal deployment, if you're doing bare metal, or you're running outside of a cloud environment where you don't have these hosted managed services, and you still want to run a database or you still want some block storage, Rook makes it easy to run that on the same cluster as your Kubernetes cluster. So you don't, and it uses Kubernetes itself to help manage these services and scale them and manage and do essentially what what most services would do, what the cloud vendor would do outside of this environment. Another option is to say, well, great, if I wanted to do that, well, if I wanted to, I can have my compute cluster be separate from my storage cluster. So you're able to, say, run your compute on one side of the house and still use Kubernetes to manage your stateful storage services on the other side and scale them independently. So that's another option that's available to you if you were to use something like this. So to give you an example of what Rook does, say you wanted to run let's take an example where you're on a bare metal cluster, you have your own deployment, and you wanted the equivalent of, say, a EBS or an S3 service that you wanted to run in your environment. With Rook, you can basically define a cluster using Kubernetes, configuration manifests. You could define the size of the cluster. You can define which devices you wanted to use, and then post that to Kubernetes, and then Rook would light up all the pieces required: the storage nodes, the mon, build quorums, deploy and run storage nodes to expose your own EBS or your own S3 service within your Kubernetes cluster. So that's a pattern. In this model, you are now running your storage services inside your Kubernetes cluster. And Rook does this by essentially following the operator pattern. How many here have heard of the Kubernetes operators? Great. And so essentially, it's continuously reconciling desired state, which is what you want to happen, with actual state, which is what's actually happening in the cluster. So if you were to, what's cool about this is if a new storage node shows up and it matches the desired state, then you'll see it deploy, become a new storage node, and become affiliated with the storage cluster itself. Or if something fails, then it's remedied and the system heals automatically as things come and go. And just like, say, Kubernetes does this with replica sets or with pods and deployments and others, a similar kind of thing is happening with stateful services in this case. So the other thing I talked about is that, and this is a relatively new thing that we're getting into, is the ability to provide new kinds of portable storage abstractions. So we talked about how volumes exist in Kubernetes. Within the Rook project, we are actually adding buckets and databases as a new abstraction in Kubernetes, and enabling many stateful services that sit behind them to essentially, extend the reach of the write once, run everywhere to things like databases and buckets. So you'll see us, I'll talk about how you can get involved, but definitely if this is interesting to you, you should definitely get involved in this project. So as an example, here's a persistent bucket claim, which is a new API that enables you to provision and manage and use buckets within your pods and your deployments without really knowing who the provider of the object storage is. Just as with volumes, Kubernetes gives you that promise today. And then similarly, if you wanted a MySQL database or a Postgres database, then you should be able to do the same thing. You should be able to say, I'd like a MySQL database as part of my deployment, and that you can write your app and use whichever favorite MySQL connector you need within your app. But the provider of the MySQL service could be RDS in one cluster, and it could be MySQL running in Kubernetes in another, right? That level of abstraction needs to exist, and that level of separation of concerns needs to exist for us to get to the point of write once, run everywhere, portable across clouds, portability across hybrid deployments, and that's why we're extending Kubernetes to do more and more of that as around stateful and stateful workloads. And so if you had that, you'd be able to say, now you have a choice. You could say, I can run my pods. They use a MySQL, a Postgres, or a bucket and a volumes, and they're now stateful apps, very stateful, we use different kinds of storage. And the choice could be whether the provider of the storage could be a public cloud managed service, if that's where you deployed, or it could be in cluster, or it could be in a separate cluster. At some point, the author of the app shouldn't know or care. The cluster admin should set up the cluster with where they want the storage provider how they should set up the storage provider when they're setting up the cluster. Make sense? Is this great? That's all I had. So please check it out. Again, it's a CNCF project. It's open. It's a pretty healthy community around this project. Here's a bunch of information for how to get involved. We're actively looking for contributors or people that want to help the project grow. Project has good governance and it's in good shape. So definitely help us here. If you're also interested in Upbound, come talk to me or Steve here, who's also from Upbound. And if this looks interesting, there's lots of opportunities at continuing to do similar stuff in here in Seattle. So thank you.
Thank you, Bassam.
Happy to take questions.
Do we have any questions from the room? Yes, up the back.
Hey, can you, the last bit there about using Rook to configure and run services like MySQL.
Yeah.
Can you comment on that? Sort of similar work that's being done in like a service broker?
Sure. So
the same problem being addressed.
So the question is, how does the work to add abstractions like MySQL database or bucket relate to efforts like the Open Service Broker and others?
Well, just to be clear, like bucket and the database are two very different pieces.
Definitely.
So, and especially when you get to the point where you're talking about, I want MySQL running on my cluster. I can run it or I can use RDS, and I want an abstracted way
Right.
to services so it looks the same to the application. I think that's the
That is.
service broker target.
Yes. So there's a project called Open Service Broker, which I think its stated goal is to help broker access to managed services that are running in public cloud environments or other environments. And the abstractions provided by the Open Service Broker are essentially how to provision a binding to a service and an instance of a service that is running. And so that model works if everything looks like a service endpoint and a binding to it. That model is definitely fine. In fact, you can argue Rook should use that when it's talking to things like RDS or others, right? What we're attempting to do is with the Rook, we're actually trying to provide high-level abstractions like a bucket, which could have commonality across the different providers of it. And then attempting to do a separation of concern where, just like volumes, there is a concept of a bucket and a claim, and that is vendor neutral and and also implementation independent, right? Both of those goals are not stated goals of Open Service Broker. And so I think that's where the design diverges. But we are, this is all in the open community. We'd love to figure out how we're actually talking to folks at the open source worker team and trying to figure out how do these things, come together. But the end goal is, I think, is the same. We'd like to get the goal of write once, run everywhere to actually address the majority of what people run in terms of apps and services, and not just the compute and the networking piece. That's our goal here too. Question.
So the example for the object being an abstraction, do you think the implementation can provide the SLAs that some managed services will provide? Like if you're running it within the cluster?
So that's the question is, do you think that the bucket implementation and the object store that's providing it could provide the same SLA as, say, a managed service provider would? I think that varies. A lot of it is a function of who's running the object store and what they're doing to run the object store. In some cases, some customers don't have a choice. For certain workloads, they need to have, say, on-premise and others, and that's what's available to them, and they work with a vendor, right, to do that. I think what we're seeing is essentially there's a fair amount of automation that has been built to run things like object stores reliably. A lot of that automation today is in public cloud vendors, and they obviously give you an SLA and they carry pagers and they do the whole thing. So one of the things to think about is if the automation increases to the point where, through things like operators and others, it becomes, say, it gets you 80% of the way, would it be efficient for an enterprise to run with the 20%, just handle the 20%? And I think the folks that are running any kind of stateful storage services in-house are doing that today. Is it the same SLA? Well, it's hard to say because there's no SLA contract between them and themselves, or at least, but that's that. I guess the thing that's more interesting to us is that the choice should be available, as opposed to it's one or the other, right? And certainly if you change your mind about where you want to run, you shouldn't have to go rewrite your applications when you do that.
I have a question. Oh, you go first.
Yeah. How does data persistence and data loss recovery work in this tool?
So the question is, how does data persistence and recovery work in this tool? A lot of that is a function of the actual storage provider itself. So if you're looking at something like Ceph or Minio or CockroachDB or others that run on something like this, they all have provisions for recovering data and resilience around failures and dealing with failure cases. So what this provides is the ability to kind of marry that with Kubernetes, so that if a node fails in Kubernetes, that the storage provider can actually trigger its resilience facilities or healing facilities, or if things grow and scale, that as you add nodes, that the cluster itself grows and becomes stronger and faster. But each of the storage systems have very different ways of dealing with that. Ceph does it one way, Cockroach does it a different way. Some use erasure coding, some use redundancy replicas, and it varies by storage system. Rook is an orchestrator that sits on top of those. It's not actually the one that's doing the recovery and resilience. You had a question, Nathan?
That's actually what my question was. Thank you.
Okay, great. Awesome.
Anything for... No?
Thank you, guys.
Thank you.
Of course.